Hello. Today's example here is that I wanted to show you how we interpret the results of Monte Carlo simulation and how Monte Carlo simulation looks like. And today I have an example for a cost estimate. So we have here the quantities where we have our most likely value and its range of uncertainty. It can be less by like 5%, that can be 95% of the original quantity, or can be maximum by like 130, and the same goes for each example here. And then we do like total probabilistic value, which is we can calculate the probabilistic value for each item. For example, here we're applying the PERT equation. And then we have the minimum and the most likely and the maximum for the unit prices, as this is another uncertainty that we have in our estimate, and also the total probabilistic values for each line item. And then we have our deterministic value, which is the multiplication of our most likely values. For example, the cost estimators or the quantity surveyors quantity takeoff, and the unit prices that were estimated by the cost estimators. So this is our deterministic value. And finally, we have our total probabilistic value, which is the multiplication of the probabilistic values that we have here between the quantities and the unit prices. And then we say, okay, let's run a simulation like 1000 iterations. Now you see the values are iterating now, giving us thousands of iterations. Each scenario we are assuming a different set of values and getting this information and data. That is what is the essence of Monte Carlo simulation. You can do thousands and thousands of iterations that cannot be humanly possible to be done by a human being, but it can be easily done by software. And so it gives you what we call the information and the data that as close as possible to the real life information that's going to happen in the future based on the inputs that you provide. So we're now waiting for our iteration to finish. We have here it's counting here and I'm almost close to finish, and now I guess it's now finished, and here we have the results. So we're having here the results is saying, for example, this is the 1000 iteration for fabrication quantity. This is 1000 iteration for piping erection quantity. This is also for sandblasting. So each time it had different quantities for every iteration. You see the iterations here and so on. So, and then we have our simulation statistics, is saying our mean and median, the minimum and the maximum. And then we have our curves. We have the CDF, or cumulative distribution probabilistic curve, where from here we can extract our P80 and P90 or P10 and P50. But before we go there, I want to show you this curve. This is the probability density curve that is showing you at each point how many times the total value or output was there, which is our total probabilistic value. So for example, you find here this value is the most probable value, but this is just an histogram. It's showing you how each point is repeated, but it's not an indication that you can calculate from it that how to calculate a P80, P90, P70 or P50, whatever the value you want to calculate. You have to calculate that. You have to do a cumulative curve for this one. So the cumulative curve for this one is our cumulative distribution or probabilistic curve, or what we call sometimes CDFs for its probability function. So from here it is just continuously summing each value for each column and going up there till we sum the total cumulative value for all this histogram. And from this curve you can extract the P80 and the P80, the P50 and the P10 if you want to. So let's do like an example here. So for example, we have here, let's say we want the P80. You can go there and just draw down a line, hit the curve and draw down a line, and this value should be our P80 value. And if you want the P50, the same thing to do is go there. Okay, just repeat this. Go there and hit the curve and then go down there, and you can get your P50. So So whatever the thing is that you have now your P80 value, 80 P80 value, and the P50 value. And what does this represent? It represents how much you are confident you are not going to exceed this value. So let's get this here also from this table. You can get and extract the value itself. For example, the P80 is 1,666,4, and the P50 you can get here from this table is 1,584,74. So basically speaking here, we are just saying that this is how we do a Monte Carlo simulation. A very simple way. I'm not getting into much details. I'm not giving too much complex information about this, but I just wanted you to understand how we interpret these curves, how we understand it, and so on. And before we leave, I want to show you also the tornado chart. The tornado chart is the most influential. It shows you your most influential items in your Monte Carlo simulation model. For example, here we have sandblasting. This is the most influential, then piping and painting. And so this is just showing you what is the most influential value items in your model that you're building. So you can audit these items and recheck if the value is okay or not. And from this point you can check if the model is correct or not and redo the model again. I hope this short video was helpful for you guys and give you some information, and I explain much more in my QRM or Qualified Risk Manager course and certification, and we get in much depth details and give real life examples of how to build a quantitative risk model for cost estimates and also for schedule. And eventually its objective is to make you a qualified risk manager that is fit to any risk management job, and also have the expertise and experience to become a risk manager. So if you're interested to be a risk manager, just DM me or send me an email, or just call me, WhatsApp me through my free helpline that on my web page, and I will be more than happy to help you. So thank you and goodbye.